Hi everyone, this is the Biofeedback and Performance Group, and we're so excited to be able to share with everyone what we've been doing this summer. My name is Yui, and I'll be giving an overview for our project. The leading question that our group wanted to investigate was, do actors experience real emotions when performing? Namely, when actors are on stage and they express themselves and they perform, are they actually experiencing a change in their physical body, or are they just quote-unquote acting? In order to answer this question, we based our investigation off of certain premises, which I'll talk about later. The timeline for our project was to be able to create a device, create a prototype that took data from actors in real time and then analyze that data to show what actions they were feeling in the moment. We based our analysis off of one of three main theories of emotions, which was the James Lange theory, which stated that physiological changes were the consequence of the emotions that we are experiencing. After we collected the data, we plotted the data that we got on a two-dimensional scale of valence and arousal. Valence talked about the positive versus negative emotions, while arousal talked about the heightened or not heightened state of emotions that an individual is in when performing.
Hi everyone, I'm Stasia and I'm going to be going over the hardware today. So our biofeedback device utilizes the RP2040 microbus development board, which then connects to the sensors and electrodes that are placed on the user. To briefly introduce our sensors, the ECG sensor measures the electrical activity of the user's heart, showing us heart rate variability. The GSR click measures the galvanic skin response of the user, which is essentially any electrodermal output. The heart rate click measures the user's pulse and beats per minute and blood oxygen saturation. And finally, the EMG sensor measures electrical activity in the muscles generated by movement and contraction. The code uploaded onto the development board using Arduino can then allow the data collected from the sensors to be recorded for interpretation.
I'm Gabriel, and I'm going to be talking about the software. So we tried out different programming languages and different IDEs. So we started off with MicroPython and CircuitPython. They both had their pros and cons. Like CircuitPython seemed to be the right one for our board, but there were not enough resources online for us to code the sensors. And MicroPython was a little harder to use, but there were a lot of online resources. However, it was not working with the sensors, so we ended up choosing something else. So with the IDEs, when we were working with MicroPython and CircuitPython, we used we tried out the Mu editor, Thonny, and VS Code. But in the end, we ended up using Arduino and C++ because it allowed us to upload the code onto the board, and it had the serial plotter and serial monitor, which is a very convenient way to display the data we got from the sensors. And after we got the data from the sensors, we exported it from the serial monitor into the Google Colab, where we had a Python script which graphed the data. And for the BLE click, which is essentially a Bluetooth device attached to our board, we used a software called Smart Snippet Studio and a software on our phone called Smart Console.
I'm Jay. I'll be going over the ECG data, one of the devices that Stasia talked about. So one device that we experimented on was this ECG device, which measures the heart rate variability, or HRV. So when you have a high HRV, it means that your body is responsive to stimulus, indicating that you're capable of adapting to your environment and performing at your best. This ties in with our design question of whether or not actors really feel what they're acting, with our hypothesis being that a high HRV corresponds to an actor that is really in touch with their feelings when they're acting. We measure the HRV by examining the QRS complex, which represents the spread of stimulus through the ventricles of the heart. There are two ways we do this. First, we look at the amplitude of the R wave, which is the peak you see, which signals greatest ventricular hypertrophy, or like the greatest expansion of your heart, which indicates emotional stress. Next slide, please. Here's a zoomed in and zoomed out version of my ECG data. So we can see the QRS complex on the top right, which is a very zoomed in version of the data. But in the zoomed out data, you can see that they're actually in our data, we could see that there are three clear peaks in the R wave amplitude, representing times that I almost jumped out of my seat watching a horror movie. And we also noticed that my heart rate variability increased over time while watching the movie, representing a larger and larger emotional stimulus. The second way we interpret HRV is by plotting the distances between the R waves, also called the RR interval, onto a Poincare plot, which we can visually use to represent the HRV variance.
We would like to thank our wonderful professors for their guidance throughout this project, as well as our wonderful mentors who helped us through every step of the process. Finally, we want to thank Collettiva Teatro for the wonderful collaboration. Thank you.